Alright, so I wanted to make this for a while because Vermicelli's disassembly and commenting of the Contra code is just incredible. So I thought it might be fun to do a quick video. Well, this might not be that quick. Well, we'll see how it goes. I'm kind of doing this off the cuff. On how to actually use this to make your own ROM. So one of the big benefits of this is that you can actually do what's called compiling all of his work and make a real Contra ROM. So you can take all of the source code, as it were, that's commented and explained and documented, and use it to create a NES ROM file that you can play on emulator on NES. So this makes making ROM hacks like super simple to do. Well, relatively speaking. So how do we do this? How do we actually take all of Vermicelli's work here and make our own ROM that we can play? So I'm going to walk through what you need to do that and everything, the whole process around making that happen. And it's really pretty simple. So let's get started here. So Vermicelli put all his work here on GitHub, which is, if you're not familiar with GitHub, it's a code repository. So anybody that creates code for programs, you can put it up here. It's a really easy way to have it open source and have the community of work on it or look at it, review it. So it's just here for public consumption. I'll put the link in the comments so you can just click and go. But this is where it lives. So he's got all of the file structure here for everything, and it's all commented. Everything is all here. What you'll see when you go to GitHub, anything you do with GitHub, there's the name of the repository will be at the top here. You'll see all of the structure of this particular repository, all the code that's here, and then there's comments for all the commits that have happened, and then usually below that almost always will be the readme.markdown file, and this will have a description of what it is and how to work with it. So you should read this if you have any desire to actually build ROMs and work with this. You should read through this. It's not very long, it's pretty simple, and it's all pretty helpful. So there's some instructions on how to build it here. Well, sorry, first of all, a little overview of the structure, what is in where. So when you're looking through the folders, you can find out what's where. This SRC, the source of the game, that's the big one. That's where we'll be looking at stuff. But this docs folder also has a lot of really good stuff in it if you want to understand how it's put together, what goes where. The debugging files are good for the emulators if you want to do debugging. Some Lua scripts that were built to kind of play with stuff, some collision detection stuff. Anyways, you can look through that and see what's in there. The source code, that's the actual source code of the game. These build files are what we'll use to actually build the ROM, so they'll kind of automate that whole thing. The README is what we're reading right now, and so on and so forth. So I won't read all of this to you, but you should go through and read it. It's worth your time. It's a quick read. It's only, I don't know how long here. But it does just kind of give you an overview of everything. The building is, we'll do that here in a moment. It gives you the prerequisites, and this is actually one of the things we need here is this compiler for building. So we'll come back to that again in a moment. Here you go, full instructions on how to build. So this is what we're actually going to do. There are 3 build scripts. I'm going to do this one in PowerShell for Windows. I'm not a Windows guy, but I figure it'll probably get the most use, so we'll do Windows PowerShell here today. So the build.ps1 script is the one we'll be using to build. Documentation, so this kind of explains the docs folder that we just talked about, and then getting started. So like I said, I'm not going to read all this to you. Go through, read this, the rest of this, and you'll kind of get an idea of what's going on. Project history is interesting. I mean, it's always cool to understand someone's thought process and why they did this. This was a ton of work, without a doubt. Doing all this was a ton of work, so props to Vermicelli for all this. Okay, cool. Let's just get on with the meat and potatoes of this stuff. So what we need to do is, first of all, we need to get a copy of all this. So for this particular purposes, we're just going to download a copy of it. If you're interested in working with Git and GitHub, There are other ways to work with this system. You can clone, or you can fork all this code and have your own copy of it and work with it and contribute back to it. You'll see, like in the contributors, I've actually made some very, 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 very small contributions to this, but you would use Git to do that kind of thing. But for us to download a copy, all you need to do here is go to this code and just download zip, and that'll download us a copy of all of this great stuff. We're going to I've already made a folder here called Vermicelli Contra. We're going to download it right to there. So here we go. Here's our folders, and now we've got a copy of all of this. It's zipped up. That's not going to do us any good, so let's unzip this, and we will just extract it to here in the default. Yay, waiting. So I'm just using the same name. So Nest Contra US main is the name of the repository. So get rid of that. So here we go. So Nest Contra US main is the branch that we're working in right now. Don't worry about that. So here we go. We got our own copy of all this now. So for working with this source code, it's all text files. Me personally, I like using Notepad++. As opposed to regular Notepad. Don't use WordPad, don't use Word. You need a text editor for this. So again, my recommendation is go get Notepad++. It's a very well-known and awesome text editor for Windows. I'll leave a link to it below. And again, we'll go into source. So here we go. Here's all the source code that we looked at. So if we want to look at these and just edit a note, I'm going to open the constants file here quickly. So this is all of the RAM values that are used in the game. So you can see every value that's used has a name assigned to it and then a description of what it is. Some of the more fun ones that we all know and love are things like down here in 9.4 is our player jump coefficient, also known as the jump value. Which have links to Mr. K's and Archie's videos in here in the descriptions that Vermicelli's made. Some of the other things that we know of, so things like we can actually edit these. These are just values that are stored in memory. So this is a document that shows you what RAM addresses are used. You could use this to make like Game Genie codes and other cheat codes, but you can actually use this to make a ROM hack. But this tells you everything, where it's stored, where it is, description of what it's used for, and then a name given to it. So these names will be used in the source code. So when you are looking at the actual code of the ROM, these names will appear in the code as opposed to just raw RAM addresses, which is this middle column here. So previously we didn't have this kind of documentation done. When we were looking at the source code for the game, we would just see these raw numbers and we wouldn't know what they meant. So now that Vermicelli has gone through and identified the purpose of every single address, we have descriptions and names that we can use to reference really easily. Player frame scroll. This is another one that I've been working with a lot lately. How much player 1 is causing the frame to scroll by, and then that's at $A2, $A3, which is not listed here, is for player 2. So when a player is causing the screen to scroll either to the right or up, with the only two ways we can scroll in Contra, this is the value per frame that says how much to scroll the screen by. So more useful stuff there. Current weapon, there you go. That's the current weapon that player 1 has, current weapon player 2 has. Invincibility timer. I mean, like I said, it's all documented. It's all here. You can read through it and see exactly what is used for what. So another one that will be useful is Bank 7. I'm not going to get into structure of NES ROMs, but you can find a lot of that on like NestDev. But Bank 7 has a lot of the core game code in it. And it's all documented and written here, so you can read through these and see the exact same kind of thing. A bunch of import statements that are used just to link everything together, import exports. But a lot of the main game code runs in Bank 7. Handle sounds for PPU, I won't read all this to you, but yeah. So okay, so here we go. So now we've got a copy of the code. So great. How do we compile it? Okay, so let's go back to the GitHub repository here and go back to building. So like I said, we do need a copy of the CC65 Compiler suite. So this is a compiler specifically for the 6502 CPU, which is what the NES has in it. So I'm going to pop over here, and you can just scroll down and grab a Windows snapshot. So we'll just download the Windows snapshot. Let this do its thing. Let's get rid of this here. There we go. Okay, so I'm going to put this in the same folder I have as the other one, the other zip file that I downloaded. And now that we've got that, we'll go back over here, pop back up. Okay, and so here we go. So here's our compiler now. So let's unzip this. Again, we'll just use defaults and extract it here. So the compiler is what actually takes source code and converts it to the binary language that our machines can run. So the act of compiling is to take that source code and create an executable, as it were. In our case, it'll be the NES ROM that we can load on our emulators or on our Ever drives. Alright, so there we go. So we got this. That's there. We don't need to worry about that right now. I'm just going to close that. Okay, so now we are ready to compile. But there is actually one step further. So with these build scripts, like I said, we're going to use the PowerShell one. Let's go back here a second. And back here. So go to the instructions, 3 build scripts in the repository. They all do the same thing. Yay! Okay, but we're going to use the PowerShell script. So PowerShell script recommended for building on Windows machines. Some user reported needing to run the script to admin access to access base rom.nes. Okay, so if we encounter that, we'll deal with it. Additionally, on older PowerShell versions, we might have to do that, but I'm not sure what version I'm on, so we'll figure it out as we go. Okay, so how do we run PowerShell? So if we just go to Windows and just type in PowerShell, here we go. There it pops up. Oh, that's not what I want. Get out of here. Go to the Windows prompt, type in PowerShell. There we go. Okay, now we've got a PowerShell. Okay, so I know this looks like command line stuff. Don't worry, we won't be here long. This is pretty simple. We can do this together. Alright, so it's going to pop me in my home directory, which is right here. Like I said, I created another directory called that. Actually, where's my thing here? So I created in my documents this vermicelli Contra. So here you can see the contents of my directory. It's actually in my documents, so I need to change directory into documents. And then from here, I can see I've got vermicelli Contra US. So we're going to change directory into there too. You can use tab to complete these. Just start typing a little bit out, press the tab key, it'll complete it. So you don't have to type the whole thing. Now that I'm here, I have my 2 zip files and my 2 other things. So I need to get the CC65 into what's called my path. So this is really the only real nerdy part that we need to do here. So I'm going to switch into there, into that directory. Here's everything that's in there. Great. Okay, so how do we set our path? I'm just going to use this simple shortcut cheat command that I have on the web. I'll put this in the notes as well. Oops, that's not what I wanted. Go back there, back to my PowerShell. I can just copy and paste that. Done. Okay, I now have the compiler in my path. So nerdy stuff done. It's dot is moved to the directory above me, so I went back to Contra, and now I'm going to go into this the source code directory that we made. So NES Contra main. And now here you'll see, oh, I gotta go twice. Okay, so we'll do it again. I've got duplicates. Lovely. Yeah, so just pay attention to how it unzips on your system. So on mine, it unzipped to doubles. But dir is directory command. It lists all the contents of the directory so I can see where I am, see what's there. And okay, so I move down here, and now we've got the build ps1 shell file that we have. But there is one other thing we need to do, because we did read all the instructions, right? So where does it say to do this? I know that I need to it's not even in here. Oh, that's weird. I thought he had it in here. Okay, anyways, I know we need to do this, so let's just do it. We need a copy of the ROM. Obviously, Vermicelli can't distribute the ROM. It's not his property. It is owned by Konami, so we need a copy of the ROM to work with, to get all of the Konami copyrighted content that's not included in his source code that he has. So where do I have this? Oh, and now I'm unprepared. So I know I have this somewhere. Do I have it? No, it's not there. Where did I put all this? I don't think it's in any of these. Actually, here, let me just find out where it is. I know I have it in my... there we go. It's oh, it is in TAS. Okay. So back to my documents. I've got this TAS folder I have here, and I've got a copy of Contra USA NES right here. So let's make a copy of that. We go back over to where we have everything. Go back to our source code folder where the build files are, and we'll put a copy of this here, but we need to rename it to baserom.nes. So there we go. So I just renamed our Contra, our standard NES Contra ROM that I've legally obtained through dumping my own cartridge to baserom.nes. So there we go. So the MD5 yeah, place a copy of the US NES version of Contra with the name baserom.nes in the project root folder. Okay, so it is here. Sorry, my bad. So that's what we just did. The MD5 hash of baserom should be this. If you have a good way to do MD5 hashes, do it. If not, you'll get an error when this happens, when we go to build it. So you'll know that your ROM is not actually a proper ROM. So what now? We've got all the pieces. Here we are back in PowerShell again. So we've got our baserom.nes, and we've got the build.ps1 file. So we will do /build.ps1 and hit enter. Now this script is going to do its thing. We will sit here and we will wait for a moment. In awkward silence. So hey, how's everybody's week been? Anybody know any good jokes? Maybe I'll just fast forward this part when I actually do the... Whoa, look at all that go. Why did it do that? Wow, that failed. That's not supposed to happen. I know why that happened too. It's because of my path. Why did that not work in my path? Here we go. Let's do live troubleshooting. Yeah, it's right there. Did we get the path wrong? Let's double check that. Alright, so back up here. We want to go into CC65. Oh, I know what I did. I need to make this bin folder part of the path. Haha. Alright, so There's what a mistake looks like. And I know I'm not going to be able to figure it out, but that's okay. So I'm just going to redo this little snazzy thing here. Oop. And stop it. There it is. Okay, so now bin's in here. Okay, so my bad. Need to put the bin directory, which is short for binary, the binary directory in there. Alright, and we'll go back into our NES again here, and let's try this again. Build dot PS1. Oh, dot. Okay, round 2. Wow, that was much faster. So it already had pulled all the assets from the other ROM, had them stored. So this time it worked, creating .NES ROM. File category matches now. If we look at the contents here, we actually have a new, so we got base ROM.NES, but we also have Contra.NES. That is our new ROM that we just created. So now we can open that. Let's go find our vermicelli. NES Contra main, Contra main. So base ROM is the original ROM that we had. This one you can see by the timestamp, and the clock down here in the corner was literally just created a moment ago. And there we go. We got a ROM. We have a working Contra ROM that we just compiled. Yay! Okay, but what do we do with this? What the hell do we do with this? Okay, so you want to make a Contra ROM, a ROM hack. Well, let's go back to NotePad++ that I suggested a moment ago, and let's go take a look at this. Actually, let's see if we can do a quick ROM hack here. I'm forgetting all my stuff. Okay. So I have an idea on how to do a quick example of a ROM hack. Let's see if I can actually pull this off now. Okay, so we have our source directory where everything is, and I'm going to look at bank 7 here. The one that we was talking about where the main game code is. So what if we wanted to make the Konami code permanent? Like, you don't have to enter the code. Let's just start with 30 lives no matter what. How do we do that? Well, that's a good question. Let's do a little searching here. So let's see if we can find the Konami code. So I'm going to search for Konami, because now this is all commented and descriptive, and we have names in here. And look at this. So we found something already. So store Y. All this stuff here is going to be instructions for the 6502 CPU that's in the NES. You're going to have to do your own research on this, sorry, but we can still read the code and try and understand what's going on here. So Konami code, number correct. Initialize the Konami, check to 0. Okay, so this is initialization. This is getting right off the beginning here. First game routine, pointer table, this label initializes. Yeah, so we're still in the intro scrolling effect. This is probably not what we want. Let's keep looking here. So it's going to run through all of these values. Check if current input is part of the Konami code. Okay, so it's checking your input as you in the title screen as we run through Konami, or as you try and input it. These are all just more lines for that. Try and keep this search window. I can't make it any smaller. So I'm just going to kind of brute force this a little bit. Let's see, so Konami input check, so this is buttons pressed, only care if it's from the D-pad. Compare with the Konami code sequence. So this is all a code that's checking to see if you've inputted the Konami code on the title screen. Since Konami code since incorrect, set Konami code num correct to FF. Okay, so that's obviously not right. So Konami input check. So this whole block of code here, vermicelli is named Konami input check. So it's checking for the code. Input index correct. What do we got here? Yeah, so this looks like Yeah, okay, so here we go. So Konami input index correct. This block here is checking to see if you've inputted all 10 inputs of the Konami code. Konami code's 10 inputs compare against how many successfully entered. Konami code not yet fully entered, so at this point you would be at like up, or down, or left or right, left, right. You're halfway through the code, and then finally gets your Konami code successfully entered. And then it stores the success. So this here is the code that runs when you've completed the Konami code. And now the game is going to give you 30 lives. So cool. So it has stored the number 101, the value 01, into this RAM address. This was the RAM map we were looking at before, so we can go back and find out exactly where that address is if we wanted to. Okay, cool. Well, so I don't know if we can really use this. So this is checking for input and then stores this. And because we can't set RAM values in the ROM, that's not super helpful. But it must use this flag to set the lives at one point, right? I mean, it must know that you've entered the Konami code, so instead of setting you to 2 lives, or 3 lives, however you want to look at it, set it to 30. So maybe we can search for lives instead. Oh, there we go, 30 lives code. Oh, hey, look, there's the Konami code lookup. That's what it was comparing against earlier. So that's where the Konami code is stored, the full thing, so it knows what it's comparing against. Interesting. Okay, store a P1 num lives. Where are we? This is the demo stuff. Okay, this is just setting lives in the demo. So it actually loads 62 and then stores that. Oh, weird. Okay, interesting. But this is the demo part. We're still in set demo level here, so it's just continuing through. What else do we get? Oh, here we go. Actually, that's where initialize player score and number of lives. Let's just get down there. Okay, so init score player lives. What do we get here? Clear CPU sprite buffer, graphics buffer. Not helpful. Let's keep going. Oh, init player lives. Here we go. Okay, so this is initializing our player lives. Start with 2 lives. And then 30 live Konami code. So if the Konami code equals 1. Yeah, okay, so here we go. So it's grabbing, it's hard-coded to load 2 lives. And then it grabs the status of the Konami code. So if we've successfully completed it, we already know that it has a 1 in this value. If we have not completed the code, it would be a 0. And then, so BEQ, so this is branch on equal. So it's doing a comparison to check if Konami code status is not set. So we know it is set. Then just 2 live set. So if it is set, it'll set 30 lives. If it's not set, it'll do 2 lives. But here we go. This is probably a great place to do this. So we have 2 lives here. And it tells us, so when you're working with all these numbers, they're also in hexadecimal. So we've got a nice explanation here that says Konami code status is active. So set lives to 1D, 1 delta, which equals 29 in decimal. So 1D in hexadecimal equals 29 in decimal. So why don't we maybe just modify this? Instead of starting with 2 lives, though, why don't we just start with 1D lives? So now no matter what, whether the Konami code is set or not, we'll have, if it's not set, we get 1D. If it is set, we get 1D. Okay, I think that's how we do this. Okay, cool. So let's do this. Let's save this now. I'm just going to Control S it to save. I'm going to minimize that. I'm going to go back to my PowerShell window here. Actually, let's go back to here for a second. Contra NES. Let's move that to the garbage. Actually, I'll just hit delete. Delete. Okay. There we go. Let's rebuild the ROM now that we modified that value. Boom, new ROM. Here we go. Contra NES has been rebuilt. Let's grab our emulator. Recent is my, actually let's just do the full thing here, right? So The same thing. Here's the ROM I just built. 7:37 p.m. Yeah, just a second ago. Let's open this up. Okay, we'll go to our title screen. Let's see how many lives we got. Wow, that's really loud off my laptop. Rest 30. Look at that. We didn't even have to enter the code. We just created our first ROM hack. So, very cool. Okay, let's quickly recap this then. There you go. Full Metal's up there. I've got 30 lives and I did not have to enter the Konami code. So, back to NotePad++. So yeah, at the end of the day, all we had to do was just change this one value right here to the amount of lives we wanted. And now we will start the game with that many lives no matter what. So that was in Bank 7. Now, if you actually want to create ROM hacks, you want to learn all this, there's a shit ton of more stuff you're going to have to learn and read and figure it out. But, you know, like I said, Vermicelli has done just an amazing job in documenting all this. Go to his repository, read through all this, read through his doc section, because he explains how he documents it, what's where, what banks contain what stuff. So I know I just kind of jumped to Bank 7 because I know that. Obviously you may not know that, but if you look at how NES ROMs are structured, you'll know that Bank 7 contains things like that. So it's a great place to start. But what's in the other banks, it's all explained here. You know, I also knew that the what did he call it? The constants was the RAM. Again, you may not know that obviously right off, but with a little bit more reading and learning, you'll figure out very quickly what these things are. But yeah, know that these constants are RAM, so it'll kind of help you with understanding what's where. There's some stuff on debugging here if you want to get into debugging. Yeah, so it will take work. It's not the easiest thing in the world, but hopefully this gets you started on at least building your own ROM. You don't have to hack anything. You don't have to build a ROM hack or create a ROM hack if you just want to build a ROM. If you just want to build your own ROM and run your own ROM from source, this is how you do it. So, yeah, I know I made that mistake on the PowerShell Path, so make sure that you get that correct. I may not edit that out. I mean, mistakes are mistakes. So I know you may not understand what all the errors were, but at least you can see what I did wrong, and maybe, you know, when you're looking at your own stuff, kind of figure out what it is. So, but yeah, that's how you can get started with building your own ROM from Vermicelli's disassembly of this, and hopefully this makes your life easier. All right, that's all. Catch you later.